Okay, here's a loop. That's the whole thing. Full range. And that's the same loop with the low end taking off it. I've simulated a small speaker there. I haven't measured one, and the difference between those two things turn out to actually matter, so I'll come back to that later. The advice you've heard for this is to saturate the bass so it survives. That advice is right. The reason people give for it is missing the part that decides whether it actually works. So what does a small speaker actually do down there? I went looking for the published number, the one everybody cites, and there isn't one. There just isn't no published universal cutoff for phones, for laptops, or for small Bluetooth speakers. No standard, no database, no class figure. What exists is a pile of individual measurements that don't share a method, so they can be averaged into one. And they just spread enormously. One small Bluetooth speaker measures 112 Hz at its -3 decibel point. Another has no meaningful output below about 300. So if anybody tells you phones roll off at a number, the useful question is which phone, at what volume, and how it's measured. And here's the measurement I actually did manage to find, and it changed how I think about this. A lab measured a 2015 13-inch MacBook Pro. Asked for 125 Hz, its total harmonic distortion was 75.5%. Same lab, same table, same frequency. A Yamaha studio monitor came in at 1.4%. A good pair of headphones, 0.3. The paper says the thing that keeps it honest, so I will too. The sound pressure it managed over that range was very low. It's a big percentage of a small amount. But just sit with it. The speaker is already turning your bass into harmonics, badly, and without even being asked. Start with why the advice works at all. Play 3 tones together. At 300, 400 and 500 Hz, and you hear a note at 100. There's nothing at 100 in the signal. A 100 is the greatest common factor of the 3. Your hearing gets it from the spacing, not from the energy. And this thing has been measured and remeasured for more than 60 years in 4 separate papers I can point you at. There's a limit on how much of the signal is even available for that. Only the first 6 to 8 harmonics gets heard as separate pitches. Past that, they stop being individually resolvable. And the timing route your hearing uses for pitch has a ceiling of its own. Because neurons can't fire faster than about a millisecond, so it runs out above roughly a kilohertz. So here's the part that falls off on the way to you. Where you put the harmonics decides whether any of it works. If the lowest component left in the signal sits above 5 kHz, you get no virtual pitch at all. And for a 50 Hz fundamental, the lowest surviving line has to be at or below about a kilohertz. Only harmonics up to about the 20th contribute anything to it. 2 harmonic stacks, same fundamental, and it's absent from both of them. The first one keeps its partial down low. And the high one is the same stack moved up above 5 kHz. Level match, nothing else changed. The high one just sounds brighter. No weight arrives with it. That is what a saturator does when its harmonics lands too high, and it still gets called warmth. The model that predicts any of this weights the components it listened to most heavily around 600 Hz. That's a number inside a model rather than a measurement of your ear, and it still tells you which octave you're aiming at. And the engineers who built this for a living land in the same place without quoting that book. The free systems I read put their harmonics in the low 100 of hertz. One feeds at distortion stage 20 to 70 Hz and takes its output at 70 to 140 Hz. One more detail, small and checkable. The note you hear this way sits a little below the real fundamental. About 3% flat at 60 Hz, about 1% at 400, and level with it by the time you're above a kilohertz. And that came out of a setup I can tell you. The complex at 50 decibels, the matching tone at 60 decibels, harmonic flat to 500 Hz, and then falling 3 decibels an octave. It's a real figure with a real bench behind it. Which suggests a saturated bass can read slightly flat against a sub that still has its fundamentals in it. That's my inference from the figure. I haven't measured it. So what do you actually do? There are listening tests on this, and the answer is yes, with conditions attached. So the clearest one, 15 listeners, double-blind, 24 paired comparisons, 4 rock and pop tracks through a small portable speaker. Every enhanced version did beat the untouched one for bass quality. A later test, 16 listeners found the same direction and asked one more question. Bass impression went up, audio quality went down. The same process files were rated better on bass and worse on quality than the file that hadn't been touched. And that's the trade. It's in their data, not in my opinion. And here's what none of them measured. Not one asked whether anybody heard a missing fundamental. They asked whether the bass was better, or stronger, or more pleasant. The mechanism I just spent 4 minutes explaining is not the thing these tests verified. The authors of the first one even say the loudness increase people assume was never formally checked. So the rules, and they come out of the papers rather than out of me. 1. Feed it a narrow band. That same paper says once the input into the distortion stage spans about 3 octaves or more, intermodulation becomes clearly audible. 2. An octave-wide output band is usually the good choice. Wider gets sharp, narrower leaves too few harmonics to do the job. 3. Aim relative to where your speaker gives up, not at a fixed frequency. The commercial system in that literature picks which harmonics to make from the speaker's own cutoff. And 4. The device may already be doing it. JBL documents a bass booster that lifts the low end at a low volume. Sony ships a bass emphasis mode switch on out of the box. So you may not be adding bass to a bare speaker, you may be stacking your saturator on top of processing that is already moving your low end. So the advice holds, and it holds with a condition. Saturate the bass. Put the harmonics low enough that your hearing can use them. Keep the band narrow and accept that rated bass can go up while rated quality goes down. Then check it rather than trusting it. Anything playing back through one speaker is getting the mono sum of what you made. And that's what I built Check to measure, band by band, weighted toward the low end. It's free, get it on my website if you want to. Thanks for watching, see you next time.